Morning, early birds. Welcome to my session. Today we're going to talk about Airbnb's journey from self-managed Redis to ElastiCache for Redis. This is our agenda. We're going to talk about a little bit of background on Airbnb, how Redis looked like at Airbnb, why we chose ElastiCache, our migration requirements, the procedure, which is the exciting part, and we'll do a summary. So a little bit of background about Airbnb. It was founded 10 years ago, and it used to be called Air Bed and Breakfast. Our mission is to create a world where people can belong through healthy travel that is local, authentic, diverse, inclusive, and sustainable. Today on the platform, we have more than 5 million unique homes around the world in 81,000 cities and in 191 countries. We have more than 15,000 unique activities on experiences in more than 1,000 markets. So whether you like surfing or cooking or biking, you can find something you like. This is how much data we have stored today. We have 104 petabytes, 900, that's only in S3, 940 terabytes in Aurora, and 237 terabytes in Redis. So a little bit of background of what Redis looked like before we migrated to ElastiCache. Before the migration, we had 82 clusters in EC2 that we managed. Post-migration, about a day after 100% migration, we had 113 ElastiCache Redis clusters, and today we actually have more than 146 clusters. When we talk about Redis, a lot of times people think it's just like memcached, but a lot of you know now that there's many use cases for Redis since it has a lot more features than memcached. One of the use cases is authentication, right? We use it for user login sessions, feeds for homes and experiences, verification and fraud detection, messaging, and payments. These are just some of the use cases. So we had two types of Redis architectures that we managed. The first one is called, or was called, the Smart Stack Redis. This one is pretty simple. It's got a primary and a replica instance. It's multi-AZ, but it didn't scale well. This one, aside from operational overhead, we had to manually failover when we got an alert that one of the instances was down. There was no support for sharding, and there was also no encryption support. The other architecture we had was called HA Redis, or High Availability Redis. This one had auto failover. So we had that mechanism in place. It was also multi-AZ. As you can see in this diagram, we had this service called Redis Sentinel that continually monitored our Redis clusters. And whenever there was a failure event, we did an automatic promotion of the replica and replaced it with a new instance. and published the new primary to our service discovery. The cons for this architecture was that it had more operational overhead. We had to maintain the Redis Sentinel cluster, right? That's another framework. So it was a lot of work. And a lot of people also didn't understand how that worked in the background, right? There were things such as all of the Redis clusters looking like it was one huge cluster. It was hard to distinguish which cluster belonged to a service. There was no support for sharding either, and no encryption support. And with this architecture, we started using TWEM proxy. And that posed a lot of issues such as restricted commands, right? For those of you who are familiar with TWEM proxy. So why did we choose to use ElastiCache? Because the current approach doesn't work, right? It's difficult to manage. There's poor user experience. For example, the manual failover, whoever's on call had to respond to that. And that also made it very difficult for us to scale, especially when we needed sharding. Not just Smart Stack Redis, but also HA Redis. And it was also very expensive. The EC2 instances or instance types that we had to use in a lot of the clusters were expensive instance types, very memory intensive instance types. With ElastiCache Redis, these are the features that we really liked, right? Key value store. As I mentioned earlier, we have many different use cases for Redis, right? We don't just use it as cache for persistent data stores. We use it as really fast in-memory data store itself. The high availability and reliability. As an SRE, that's my favorite. We have read replicas. We can have many read replicas and point certain services to directly read from the replicas. Multiple primaries. We can also have multi-AZ with automatic failover, right? We don't have to worry about an entire availability zone going down. And now we don't just have them in 2 AZs, we have them in 3 AZs. It's fully managed and hardened. We don't have to worry about upgrades or security patches. It's easily scalable, right? You can keep adding replicas. You can keep expanding your cluster if you use it in cluster mode. Cluster with up to 6.1 terabytes of in-memory data. It's secure and compliant. So you can have encryption at rest and in transit. You could also enforce using a password. Migration requirements. We have a very unique requirement, right? First, when we think about Redis and caching, we don't by default think of persistent data stores, right? When caching, you can just, by default, we think, oh, we could lose that data. It's just cache. But because of our unique use cases and the way we use Redis, we have these migration requirements, right? We had to have 0 downtime from switching from the EC2 Redis cluster to the ElastiCache Redis cluster. We had to migrate all our data. There had to be no data loss and no cold starts, right? Cache had to be, had to have data. How did we do that? This is the very difficult part that the ElastiCache team helped us with. We did a lot of testing first, a ton of testing, not only to test that the migration procedure worked, but benchmarking, network throughput, and all of these things. So first, we had to stage the application. So prepare to redirect Redis traffic from EC2 Redis to ElastiCache Redis. We'll go over all of these steps in detail. And then we had to deploy ElastiCache Redis cluster. So we just provision a new one. We sync the data. We do the failover, and then the cleanup of the old EC2 Redis cluster. So staging the application. Here we have to be ready to push an update to production that will redirect Redis traffic to ElastiCache. In this case, it's either a configuration change via chef or a chef role, because that's how we manage EC2 instances, or a Docker, a change in the Docker image and pushing that out for our containerized applications. We make sure the PR or the pull request is ready to be merged to redirect the traffic. Then for the new ElastiCache Redis cluster, it had to be single node cluster. I'll explain that in a little bit, right? With multi-AZ failover disabled. So it had to be a single node cluster because in order for us to replicate or sync the data from EC2 Redis, we had to make the ElastiCache Redis single node cluster a replica, right? So now we have a cluster with one master in EC2, one replica in EC2, and the second replica in ElastiCache. And then we allow traffic from EC2 Redis and the application. Right, this is what, so we manage our infrastructure in code. And this is what it looks like when we first deploy the cluster to make it a replica, the ElastiCache cluster, rather, to make it a replica. So if you can see here, replica count is 0, and auto failover is disabled. Right, auto failover also has to be disabled in ElastiCache Redis because you only have one node, right, one instance. And auto failover can only be enabled if you have replica. Syncing the data. Also, disclaimer, AWS doesn't usually support or get this much involved in a migration procedure. Thanks very much to the ElastiCache Redis team for making this happen for us. But alerting for ElastiCache is turned off at this point. So we have to keep that in mind, right? First, because there's only one node in the Redis or ElastiCache Redis cluster, and there's no primary. So we have to have monitoring turned off. So syncing the data, what the Amazon ElastiCache team enables is the slave of command, right? If you look at the ElastiCache Redis documentation on restricted commands, these are one of 4, I believe, restricted commands in slave of. So they enable that for us during migration once the node is the single node cluster is deployed in order for us to make that a replica. And then we add the ElastiCache cluster as a replica in the Redis cluster, right? So how do you do that? We just run this command. Just your plain old Redis CLI command from your EC2 Redis primary instance. So that adds the second replica to your EC2 Redis cluster. The failover. This is, I would say, the most critical part, because this is where you can, you will definitely get errors, right? So at this point, we have to block traffic to EC2 Redis, which will block all writes, right? You could still, you won't get any read errors, but your application will get write errors, because now they can't write to any of your EC2 Redis nodes or clusters. We disable the alerts for EC2 Redis. We block the traffic, and we allow this sync to finish. We have to do this so that we don't lose any data. If we don't block traffic, writes will continue and sync will never finish, right? Or if we fail over without doing so, we'll lose data, right? Not all of the data, it will get to the replica once we switch over. So we disable alerts because you're about to take Redis traffic down. You block traffic. To do this in Smart Stack Redis and HA Redis, we have to disable this thing called nerve in our Redis clusters. For those of you who are familiar with our open source service discovery framework, Smart Stack, nerve is like in our nervous system. It reports to the brain, right? It lets us know that Redis is still working. It does health checks. It makes sure traffic flows through. Yeah, and then allow sync to finish to ensure there's no data loss. And then the failover. Another critical part. Now we're at that point where our application is getting write errors. So we need to update the application configuration point to point to the new ElastiCache Redis endpoint. So in this diagram, you could see that we're writing to the EC2 primary, but we've blocked that write. And both the EC2 replica and the ElastiCache replica are syncing. So we have to push what we staged earlier in the pull request earlier for configuration management or your Docker image. So this is what it looks like for us because we're using Smart Stack for service discovery. So we stop nerve. That's how we block the traffic. And then we get the status of the replication, right? So as you can see, we have 2 connected replicas. One of them is the EC2 Redis replica, and the other is the ElastiCache Redis replica. What we want to look at here is the offset and make sure that matches. Right. So this is where you finally do your merge. Either, for us, it was via Chef and Docker image. At this point, your application is still getting read-write errors. Usually that error would look like can't write to a read replica, right? Because you failed over. You've directed your traffic, your configuration, in your configuration management, you've made the change to have your service or your application read and write from the EC2 Redis host now to the ElastiCache Redis cluster, which is still a replica, which still only has one node and which still has no auto failover enabled. So what's the next step? Now we need to promote the single node ElastiCache Redis cluster, right? We have to make that replica a master. And you just issue the slave of no one command. So earlier we did the slave of command to make the ElastiCache cluster a replica of EC2 Redis. Now we're issuing the command that it should be a slave of no one. So this is the 3 steps to do the failover, right? We promote the replica, the ElastiCache Redis replica. We add a replica to it, and we enable the multi-AZ failover. At this point, we get the AWS ElastiCache team involved again, right? So first, I do the promotion, and then this change. So earlier we saw this block of code where we have 0 replicas and we have auto failover disabled. You just make those 2 lines of code changes to enable. Oh, first you have to add a replica because you can't enable and add a replica at the same time. Once that's provisioned and ready to go, usually takes a while. It depends on how much data you have in memory. And then you just enable that. The default is enabled, so we just delete that line of code. So now we have a fully configured and loaded Redis, right? We have primary and we have replica. It's multi-AZ. You can add another replica. So we have to notify the ElastiCache team to disable the slave of command at this point so that they can also turn on monitoring for the ElastiCache Redis cluster. Because without monitoring, we can't have auto failover, right? So what do we do next? This is my favorite part, is cleanup. Now we can finally terminate those EC2 Redis cluster instances, terminate proxy instances if you're using twem proxy, right? In our case, in our HA Redis clusters, we were using twem proxy. And then we delete Redis and the proxy configurations everywhere. A lot of you may be wondering, and I'll have time for questions later. A lot of you may be wondering about a rollback plan, right? What if this doesn't work? How do we roll back? What do we do? Can we go back to EC2 Redis? You can, if you're willing to take some data loss, you can go back to EC2 Redis before you terminate it, right? If you do, so you're supposed to do some testing right after you do that failover, right? To make sure you got rid of the read-write errors, you're receiving data, you have connection from clients. But if that fails, you can roll back your traffic by rolling back those pull requests as well. But you will get data loss. Another thing you could do to avoid that is, of course, to have retries, right? A lot of retries. Recap, just a little bit of summary of what we went over. So stage it, right? Stage the application. Make those pull requests to divert your traffic from EC2 Redis to ElastiCache Redis. Be ready to merge that. Deploy your ElastiCache Redis cluster, your single node ElastiCache Redis cluster with auto failover disabled. Let the ElastiCache Redis team know so that they can enable the slave of command for you. Sync the data. So add the ElastiCache Redis cluster as a replica to your EC2 Redis. Wait for that to finish and perform your failover. Performing the failover is a 3-step process, right? We have to block the traffic to EC2 Redis, merge your pull request to make your application start reading and writing to the ElastiCache Redis node. And finally, clean up, right? You can now clean up and terminate your EC2 Redis cluster. Some takeaways that we have is that Redis is not only used for caching, right? Memcached is a very simple caching framework and can be used to cache or to use it in front of your persistent data stores, but Redis is a bit more full-featured, and you can use it as a really fast in-memory database, message broker, queuing system for scheduling, right? It's fully managed and hardened, so we don't have to worry about patching it. We don't have to worry about updating or upgrading the versions. It's got monitoring, failure recovery, and backups, right? Snapshots. You can have daily snapshots. It's secure and compliant. In our case, that's a big win for at-rest and in-transit encryption for compliance. It's highly available and reliable. That auto failover feature and multi-AZ has been really good for us, right? Especially because previously we had clusters that we had to manually fail over. It's easily scalable. Now we have sharding support, right? Where we couldn't previously scale some of our clusters because of that. We had one-offs, but it wasn't a standard. Now it's super easy. You just enable cluster mode, right? And you could do this in place. So the nice thing about this also that I've noticed is we can expand our sharded clusters in place. We can add replicas in place and all of these things. And it doesn't give us any downtime. I'll save some time for questions. You can also pull me aside later on for any other questions. But thank you.